All right, we're going to run a two-proportion z-test. What is the first thing we need to do?
Set your parameters.
Nice. And so, because we're doing a two-proportion z-test, it's going to be double the work here. So we have two parameters we need to define. So maybe we're writing super small. Now, this is your choice on what you want to use to delineate between the two proportions. In this one, it has like a first sample or an early sample and then a later sample in this period for the campaigning. So I'm just going to use P subscript 1 and P subscript 2, but your choice. You could use E for early, L for later, whatever you want. I don't care, as long as you say what it means. So I'm going to do P subscript 1 represent the proportion of registered voters who favor this candidate in the first poll. All right, so let P subscript 1 represent the proportion of registered voters who favor this candidate in the first poll. Now, if you were doing this on a computer, you would just copy that and change it to P subscript 2 to be the second poll. So we're going to just literally copy this and change it to P subscript 2. So let P subscript 2 represent the proportion of registered voters who favor this candidate in the second poll. Or early poll, later poll, whatever you want. I'm not worried about those words, as long as you know there's a difference in these polls. Okay. After we define the parameters, what do we need to do next? Hypotheses. Nice, Victor. Well done. All right. So when you do a two-proportion z-test, your null hypothesis will always be that there's no difference in these two proportions. All right. Always. You can take it to the bank. All right. Not when they're closed on Sundays. Okay. So the null hypothesis. All right. Null hypothesis. This is how I write it. I'll give you another option. Right. Both are fine. I'm going to write P subscript 1 minus P subscript 2. So if I have these are the same, right? So let's say 0.7 minus 0.7, that's going to be equal to 0. If you don't want to write it this way, totally fine. You could also write it as P subscript 1 equals P subscript 2. Bless you. Both are fine. Okay? The reason I like to do the one on the left is because that helps my brain know what I'm going to put in the numerator when I find my test statistic, my z-score. All right, so it's kind of a way to help me memorize it. The alternative. Now, this is where you got to get a little bit, like, really focus and think about what you want to do here. The question says, is there sufficient evidence that the candidate's popularity has decreased? Now, normally, when we did one proportion z-test, the moment I see decrease or get lower, I'm immediately thinking less than. But if I'm subtracting and it's getting the popularity is going down, then this P subscript 2 is actually going to be what compared to P subscript 1? It's actually going to be smaller, all right, because it's gone down. All right, so if you need to make up numbers, you can. Let's say like this is 0.8 and this is 0.7. What happens when you subtract 0.8 minus 0.7?
0.1.
You get a positive number. So actually the symbol I'm going to use is going to be greater than 0. And that is what gets kids every time. All right, so just take a moment and think, what are they asking? And how is that going to determine what my inequality symbol will be? Okay, so if you're doing the blue one, that's P subscript 1 is greater than P subscript 2. Okay. What always worked for me in high school was like making up proportions.
So it means that it was initially higher than it was now.
Correct. But students usually just focus on decrease. They think it's going to be less than when in fact it's actually greater than. It's just one of those things where you can get messed up. Okay. Questions? What's that? Yes, the assumptions and the conditions. Oh my gosh, are you guys ready? All right, now here's the thing about two proportion z-tests compared to one proportion. It's all the same. All right, there's only one additional one we have to do. At the end, we're going to assume that the groups are independent of each other. So that's the only new thing. So everything else is the same. So because I'm trying to save space, I am not going to write my titles for each of my assumptions and conditions and just write sentences. So what's going to be a good sentence for assuming independence?
What?
Go ahead.
Okay. No. I say too often. Well, I forgot what to say. Okay. Well, for the first one, you need to make two independence assumptions for both, right?
Actually, you can get around it because these are both about registered voters. So if you say in each poll.
So in each poll, one registered voter favoring one candidate rather than the next one, or each one.
There you go. So as long as you say in both of them.
Okay.
So that's how I get around doing two sentences, because you're right, I don't want to write two sentences. So I'll say in each poll. So since I said that, in each poll, one registered voter favoring, and I'm going to put this candidate, but it's not wrong to put a candidate just because I just care about this particular one. Won't affect others. Who knows? That's what we're doing. All right, so what should we check? Random. Did it say anything about randomness in the problem? Randomly, both of them? Okay, so both polls chose random voters. Okay. 10% condition. Now this one, the sample sizes are different. So you could do both, right? We've got I think 800 and 1,000. I just do the larger one. All right. But you can do both. That's fine. But ultimately, you're just going to care about the bigger one. Yeah, Thomas?
In the video, you did both. Is there any circumstance where it would be better to do both?
No. I just wanted to keep it consistent. But I'm telling you now, I only do the biggest one, when I do it. So let's do the biggest one. So what's 1,000 times 10? 10,000. Do we know where this city is? No, we don't know what this is. Does it say city? Does it say state? We have no idea what they're doing here. So we're just going to have to assume what about this place? More than 10,000 registered voters. So there are more than 10,000 registered voters. All right. If that's true, then our sample size is not too large. Go ahead.
Why do we only do the biggest one?
Because if I done the 800, what's 800 times 10? 8,000. So then when I do the 1,000 times 10, I get 10,000. So I need it to be bigger than 10,000. Okay. All right. What's the next assumption we're going to make?
Sample size assumption.
Geometry again? Side angle? The sample size assumption. All right, so 800.
Which sample size?
Say it again.
What samples do we use if we have?
We're going to say both are big enough. 800 and 1,000 voters are large enough samples. Success, failure. Now, this is where I'm going to tell you that it's okay, even though we didn't do this for the one proportion z-test. All right, so with two proportions, notice in the problem, what did they give us? Right, they gave us our sample size, and then what are these numbers, 460 and 520? the number of successes. So go ahead and just use those for our success and failure. Okay? So I got to do 4 of them, essentially, yes. But you're going to see I'm not going to do any work, right? I'm just going to write down this one was, I already forgot, 460 out of 800, right? And so that would leave me with 340 failures. What do you notice about those two numbers? They're way higher than 10. I do the other one. Was it 520? And so the other one would be 480 to make 1,000. If you want to make it, they're not going to count off this, but if you want to make it like official, put the 1s, put the 2s. But I'm not going to get that nitpicky on the test. Okay? You just have to check to make sure that your successes and your failures for both are 10 or higher. That's it. That's what I'm looking for. Okay? So both, or I guess like all numbers are greater than 10. So our sample size are large enough. All right. Now, I know there was some new stuff, as you're copying it down, right? There is some new stuff we did. We had to do, 4 success failure stuff instead of just 2, since we have 2 different samples. But so far, really nothing is new with the assumptions and the conditions. Here's the new thing, all right? And this is where they'll dock you if you forget. And I'll be honest, I forget too sometimes. All right, so what do we have to assume between the 2 poles? That they're independent. So I'm going to say pole 1 and pole 2 are independent of each other. And that's it for assumptions and conditions. We are going to do our statement, but that's it. Yes, go ahead.
What would we name this assumption?
The independent groups assumption, or for Victor, that's the IGA. Abbrev. Right, preach.
Wait, can you just include that, the last sentence you wrote in the first part?
There is no order necessary. So you could do this in any order you wanted, as long as you're doing all the stuff. Like when I grade this next week on your free response, I'll be looking for all these things. And I'll show you when we do the review. I'm not going to show you Friday. We're going to start reviewing tomorrow. But on Monday, I can show you guys kind of the rubric and what they're looking for when they're grading, when they're scoring. Okay, here we go. The conditions have been satisfied. So I will use a normal model to run a 2-proportion z-test.
Are you going to show us how to push the buttons today?
Absolutely. And I'm recording this so you can watch this until you can't. Do that. And who knows? I don't know what happens when you die, so maybe you still can. I hope that there's something more fun to do. But all right. Are we ready to transition to the math?
Yes,
It's been, how long has it been? For those keeping track at home, it's been 14 minutes and we haven't done any math. And I guess we multiply by 10. Okay. Let's do some math. So let me write down my information from the problem. So our first sample size was 800. Our number of successes was 460. And then I'm going to let somebody tell me that P hat. Our second sample size was 1,000. Number of successes 520. And I got that P hat for you, 0.52. All right, so 460 divided by 800. I think it's like 0.557. There you go, straight. Thank you. It's amazing how even after 3 hours, my brain forgets. Okay, now you saw if you watched the chicken package problem that one of the interesting things about, well, I find interesting, about doing this is that right now, what are we assuming about our two proportions? They're the same. All right. So what we do at this point, before we get a chance to actually get our test statistic, is we're going to actually pool all of this data together and find a pooled p-hat. Okay. So that's something you'll need to like show your work that you're doing. All right. Because essentially, even though I know I put that they're two different groups, we actually assume that they are the same. Okay. So this is for p-hat pooled. So I'm going to do 460 plus 520 over 800 plus 1,000. So that's the number of successes for both added together, divided by the number of people in each sample. So what is 980 divided by 1,800? I believe it's 0.54 repeating. All right, so that's new. We've never done that before. That is what we're doing for our two proportion z-test. Any questions on that? Okay, now one thing that I wanted to go over yesterday that I wasn't here, so I'll quickly touch on it. We're about to use these formulas. All right, we're about to find this z-score. All right, I want to focus just for a second on the denominator. So this is the standard error, or really standard deviation, when we say standard error because we're using our sample statistics. Okay. And to find the standard deviation of this difference, you'll notice what symbol is here. Addition. Why? Thank you, Maria. Variance is add. I told you it was going to come back. All right. Variance is add. That's why this is addition. Thomas. Oh, my gosh. It is the standard deviation squared. You're good. It's just a way to measure a type of spread. We usually don't deal with variance. We only deal with variances when we're adding two variables together. In this case, two proportions. Yes. Oh, you're going to miss that. Wait till we're done, right? The conclusion. Okay. All right. So let's write it down. Z equals 0.575 minus 0.52 minus 0. Does anyone know why I put 0 here? This is the difference that I think they are right now. What do I think right now is the difference between them? Nothing. They're the same. All right, so that's why this is here. All over. All right, try to write small still. 0.544 times 4. Is it 5.6, I think? Does that work? Oh, I think that works. I said, which one? 0.544? I subtracted it from 1. I think I did that right. Over 800. Thank you. Oops, sorry. Plus 0.544 times 0.456. Notice that's the same. But what is not the same is the denominator. So on the chicken one, I think the chicken one had the same sample size, 75. Yep. So just kind of showing you with this problem, do they have to have the same sample size? They do not. All right. I'll show you a few units from now where they will have to have the same things. But in this case, no, they do not. Exactly. That's like so after spring break. Okay. Do I do this in the calculator by hand? No, I'm going to tell it, hey, run this test because this will be a lot to do. All right. So turn on your calculator if you don't have it on yet. Do you need a calculator? Yeah.
Thank you very much.
Give me a moment. I have to turn on my rabbit. Thanks. All right. So we're going to do the same thing we did for a 1 proportion z-test, but now we're doing a 2 proportion z-test. So hit stat, go over to test. Probably if you picked one that somebody used earlier this morning, it'll all be in there. All right. But just try it yourself. Don't just be like, oh, it's there. all the way down to, I think it's number 6. 2 proportion z-test. So the one we used last week was number 5. This week, number 6. All right, so 460 for my number of successes out of 800. That was for the first poll. Second poll, 520 over 1,000. For a second poll, be careful on which one you select. If you need to go back to your alternative hypothesis, we were saying that P1 ends up being greater than, because P2, we're trying to see if there's enough evidence to say that the candidate's popularity has gone down. I'm always going to hit calculate. If you hit draw, it's just going to draw the curve for you and show you where it is. But I'd rather have all the stuff. I can do the drawing. Everybody okay? All right, hit calculate. All right, couple of things I want to point out. We'll get to the stuff that's important, like the z-score and the p-value here in a moment. But there's p-hat 1, p-hat 2, which you see we have, right? And you guys see this p-hat after it. It doesn't have anything for a subscript, but what is this 0.54 repeating? That's the pooled. So one thing I started to do in high school was I would like kind of do all this stuff, and then I would just pause, all right, and like leave it blank, and then go back after I typed it in and fill it in. Your choice on how you want to do it, but just to save time, you know, I'm not going to type it out like earlier. I'm just going to wait and then type it in. Okay? Yeah.
So you're saying to skip the part where like you wrote the...
Yeah. So like somebody went into their calculator and did 460 over 800. Just leave that alone for a second, and then once you run it, you can write it back in. That make sense?
Yeah.
All right. So our z-score is 2.328. 2.328. Let's draw our curve. Make sure to draw this curve next week. 2.328 is pretty far to the right. Yeah, on the test. Which one am I shading? To the right. Right. That's everything I own is in a box. Thanks. Gosh, someday no one will. All right. What's our p-value? It is 0.00995. I'm going to write 0.01, but I'm okay with wherever you decide to round there. Oh, good thought, Eduardo. Did I specify an alpha? No. So I always use 0.05, but this is one of those gray areas, right? If my p-value had been 0.06, don't all of a sudden be like, oh, I'm changing my alpha. Right? So go with what you were planning on using. Which, guys, in the AP exam, unless they tell you otherwise, just use 0.05.
It's the only one that's smaller than even.
Wait, on the stats list? I'm so confused. Oh, an A push. All right, well, luckily this is not A push. All right. I completely disagree. Having taken both, this A push is way harder than stats. Okay. Exactly.
A push is just learning about white guys doing stuff in the past.
That's fair. Can we do a conclusion? You're good. What are we going to do? Look at your p-value. Compare it to alpha. What do you notice about your p-value compared to alpha? It's smaller. Right? If p-value is smaller than alpha, what do? We reject the null. So do we have enough evidence to say that this candidate's popularity has decreased? Yes, we do. All right. So the p-value is below my alpha level. So I will reject the null hypothesis in favor of the alternative. Please don't stop there.
You have to give context.
Got to give context. Haven't said anything about candidate popularity. All right. The candidate's popularity has decreased.
Can we take like a 3-minute break?
We're going to take a 1-minute break. You're going to get a full timeout, not 3 full timeouts. No, you cannot.
Or if I'm really fast.
I'm not even going to go down that road.